For section 9.4, we're going to look at real-world quadratic problems. In other words, we're going to be looking at problems in real world that call for quadratics. And to be specific, we're going to be looking at work problems. We're just going to do one word problem in this section, and my expectation is you are writing this down word for word. Since there's only one of them, you're going to write one of them down so you've got a nice good example in your notes. Basically, it takes 2 carpet layers 4 hours to carpet a room together. Now, if each of them worked alone, one of them is actually an hour faster. It takes him an hour less time than the other. He's quite a bit faster. So how long would it take them each separately to lay this carpet by themselves? Well, the first thing you're going to need is the formula for work, and there is a commonplace formula for work. And basically, the formula reads, how long does it take a certain group of people together divided by how far it takes them alone, plus together over alone, equals to get the whole job done. In other words, the one represents the whole job. So if you look at it, this is one guy, he's doing a fraction of the work. This is the second guy, he's doing a fraction of the work. How long does it take him to get the whole job done? In other words, one, or the whole job. So you're looking at 2 separate guys here. So let's look at this. We know together it takes them both 4 hours. So we know on the top of both of these fractions we can go ahead and put a 4. Now alone we don't know. So we're going to go ahead and represent that as x. But what we do know is one of these guys can do it 1 hour faster. So this first guy right here, he takes a certain amount of time minus 1 because he's going faster. So it's going to take him 1 less hour, and that's where the minus comes from. This guy over here just does it in a certain amount of time, not necessarily 1 hour faster or anything like that. So now that we've got our problem set up, we're going to go ahead and solve it. I'm actually going to translate this to the next page to solve it, so I've got plenty of room. All right, so we've got a rational expression here. So of course we have to pay attention to domain, and we've got to find our LCD. Looking at this quickly, and you guys are getting pretty good at domain, I have a domain of 0 and a domain of positive 1. In other words, x cannot be 0 or positive 1. If it's 0, he's 0. If it's positive 1, he's 0, and we can't have 0 in the bottom of a fraction. We also have to find our LCD. That's the second thing we always have to find. And our LCD in this case is x times x minus 1. So I'm going to take that LCD, x times x minus 1, and I'm going to multiply each of these things by that. Now remember, we always multiply it in the top, and what happens is stuff starts to cancel, which is great. For example, right there, it just leaves us a 4x. Right here, the x's cancel, just leaving us 4 times x minus 1. And right here, it's 1 times x minus 1, or x times x minus 1. Now, of course, I'm going to go ahead. My first step is to naturally just start distributing this stuff in. And I notice I have a quadratic. Okay, the minute you see you got a quadratic, set it equal to 0. So this is 8x. I'm going to actually minus that 8x over. This is a negative 4. I'm going to actually add that 4 over and get it set equal to 0 pretty quick. Giving us x squared minus 9x plus 4. I'm actually going to use quadratic formula on this. And the reason I'm going to do that is this isn't factorable. There is nothing that multiplies to 4 and adds to 9. I'm going to use quadratic formula on this. So negative b plus or minus the square root of b squared, in this case is 81, minus 4ac, all divided by 2a, a being 1. When I multiply all of this out, what I end up getting is an 8.5 or a 0.5. Now, I went ahead and made it a decimal so I could translate it into time. Now, I'm looking at this thinking, how is somebody actually going to carpet it in half an hour? It's a completely not reasonable answer, and that will happen sometimes. Getting it done in a half an hour when it takes 2 guys together 4 hours is not a reasonable answer. Now, 8.5 for a singular guy is a reasonable answer. Remember, here's one of our guys. Here's our second guy. When we're solving for x, we're actually only solving for one of the guys. So this guy is x, it takes him 8.5 hours, not a half an hour. Half an hour is completely unreasonable. This guy does it 1 hour faster, remember? So he actually does it in 7.5 hours. And there's your solutions. 8.5 is one of your guys, and 7.5 is your second guy.